Purpose. The purpose of this experiment is to investigate the conservation of momentum and kinetic energy of a system in collisions and explosions. 2. Equipment. 1. 2.2 me PASCO dynamic system. 2. Dynamics track. Mount 3 RMS/IDS adapter 4. Rotary motion sensors 5. Experiment resources CD 6. Mass balance 7. ScienceWorkshop 750. Interface 8. Capstone software. 3. Core theory. Momentum. 1. Momentum is a vector quantity. 2. Momentum equation P equals mv. 3. Momentum is a vector quantity and is in the direction of velocity. Conservation of momentum. During a collision or explosion, the external force on the system can be considered zero, so the total momentum is conserved. Main relation. Total momentum after equals total momentum before p vector F equals p vector. Types of collisions. There are 2 types of collisions. 1. Elastic collision. 2. Inelastic collision. Elastic collision. In an elastic collision, the total kinetic energy of the system is also conserved. Kf equals Ki. Inelastic collision. In a completely inelastic collision, the objects stick and move together after the collision. 4. Setup. Setup. Steps 1. Level the track so a cart at rest does not move. 2. Use one red cart and one blue cart. 3. Attach a line of thread to each cart. 4. Run the thread over the rotary motion sensor pulley and the small pulley. 5. Open the capstone file called momentum. 6. Connect the red cart sensor to channels 1 and 2 and the blue cart sensor to channels 3 and 4 on the 750 interface. Setup diagram. Labels 1. Rotary motion sensor. Red cart 2. Rotary motion sensor. Blue cart 3. Red cart 4. Blue cart 5. End stop 6. Leveling. Foot 7. 750 interface channel connections 8. Channels 1 and 2. Red cart sensor 9. Channels 3 and 4. Blue cart sensor 5. How velocity is measured. Cart velocities are recorded using 2 rotary motion sensors connected to the carts by string wrapped around pulleys. The velocities are continuously monitored, and the total kinetic energy before and after the collision is also studied. 6. Part 2. Inelastic collisions. B. Part 2. Inelastic collisions. Part 2. A. Equal masses. 1. Use Velcro bumpers so the carts stick together. 2. Cart 2 starts at rest and cart 1 moves toward cart 2. 3. Record the velocity of cart 1 just before and after the collision. 4. Record the velocity of cart 1 in cart 2. 5. Measure and record mass and calculate total momentum before and after. Percentage difference equation. Percent difference equals absolute value of Pf minus Pi over pi times 100%. Kinetic energy. Calculate kinetic energy before and after the collision. Part 2. B. Unequal masses. 1. Place a mass bar in cart 1 and repeat. 2. Repeat steps 2 through 7 above. 7. Part 3. Elastic collisions. C. Part 3. Elastic collisions. Part 3. A. Equal masses. 1. Use magnetic bumpers so the carts bounce off each other. 2. Repeat steps 2 through 7 in Part 2A. Part 3B. Unequal masses. 1. Place a mass bar in cart 1. 2. Repeat steps 2 through 7 in Part 2A. 8. Data/analysis. Data table columns. 1. Cart 2. Mass 3. Velocity 4. Momentum 5. Kinetic energy. Breeze. Rows. 1. Before 2. After. Analysis instructions. 1. Compare total momentum before and after. 2. Compare kinetic energy before and after. 9. Final takeaway. 1. Total momentum is conserved in collisions and explosions. 2. Elastic collisions conserve kinetic energy. 3. Completely inelastic collisions make carts stick together. 10. Final message. Momentum tells the story of motion before and after a collision.